Hello, thanks for joining us today. This video demonstration will show the Forum Sentry API Security Gateway securing AMQP 1.0 traffic from Microsoft's Azure IoT Hub. The session will showcase Sentry's simple no-code interface while highlighting features such as protocol mixing, transformation, and inline data security. To demonstrate the AMQP proxy capability in Sentry, we'll utilize Microsoft's tutorial for the Azure IoT Hub and use their sample C# clients. Click the link below the video to access the tutorial that we followed. The Forum Sentry API Security Gateway enables code-free point-and-click building of APIs to integrate legacy and modern systems, connect cloud and mobile technologies, and extend business applications and services securely beyond the enterprise border. The Forum Sentry API Security Gateway converges three key functions of technology: security, identity, and integration. This demonstration of the AMQP 1.0 features in Sentry will pull from each of these categories. For API security, we'll demonstrate SSL, schema validation, threat detection, digital signatures, as well as payload level encryption. For identity, we'll look at multiple user authentication options and credential propagation. Lastly, for integration, we'll show JSON to XML conversion and mapping of data into the XML payloads. In this demo, we'll utilize Forum Sentry as a secure API gateway, essentially acting as a reverse proxy, that sits between the C# simulated device AMQP app and Microsoft's Azure IoT Hub. Sentry, as a secure intermediary between the client and the IoT Hub, will perform security, identity, and integration-related tasks before sending the message along to the IoT Hub. The simulated device client app will put a JSON message to a Sentry AMQP 1.0 listener, and Sentry will perform the following request processing on the incoming call: SSL termination, JSON schema validation, SQL injection detection, JSON to XML conversion. We'll map a transaction ID into the new XML document, sign the payload, encrypt the payload, and then finally propagate the SASL user credential when it connects to the Azure IoT Hub via AMQP over TLS, or AMQPS as it's known. Now let's review the policy configuration in the Sentry web app and interface. We'll start by reviewing the network policies in Sentry, which are like the plumbing to get the traffic into and out of Sentry. To receive the incoming AMQPS requests, we have a listener policy in Sentry. Within this policy, you can specify the IP and port for the Sentry to listen on, as well as set IP access control restrictions, user authentication requirements, and of course the SSL termination settings. Once the message has been processed at the content policy layer, and we'll talk more about that later, a network remote policy is used to connect to the IoT Hub. In this case, Sentry will be propagating the specific SASL user credentials that are provided by our simulated device client application as it connects out to the Azure IoT Hub, and of course it will be using TLS with an SSL initiation policy defined in Sentry to connect out to the IoT Hub. Sitting between the two network policies in Sentry is a JSON policy. This is a type of content policy that's designed to process JSON message flows. This JSON policy consists of a virtual URI, the Sentry virtual endpoint for the service, and a remote URI, which is where the IoT Hub service resides. This virtual directory ties together the listener and the remote network policies that we previously reviewed. Within the JSON policy, we've associated a task list. The task list will be used to implement a lot of the request processing that we outlined earlier. This will include validating the JSON payload that comes in, detecting SQL injections, converting the JSON payload to XML, adding a transaction ID into the new XML document, signing that XML document, and then encrypting that XML document. Now let's actually send some messages through Forum Sentry from our simulated device app so we can see the processing happening in Sentry and see the messages being dropped out onto the IoT Hub. So what we're looking at now is the sample client code from Microsoft running in Visual Studio 2015. And when I run this application, it's going to send a steady stream of simple JSON messages into Forum Sentry. Sentry will do its processing of that message and then drop that message on the IoT Hub. Now I have a second application also from the same Microsoft tutorial that reads these messages off of the IoT Hub. And so what we can see now on the left-hand side is our client application that is putting the messages out in JSON format. And on the right hand side, we can see our client application that's pulling the messages now, which are signed and encrypted payloads off of the IoT Hub. So now at this point, we can take a look at the IoT Hub dashboard, and we should be able to see message counts incrementing through the dashboard over time, right? We will see, of course, as messages are put out through Forum Sentry, dropped on the IoT Hub, the message rates and the counts will continue to increase, and you can use your standard monitoring of the IoT Hub resource to see that traffic hitting there. And then from a Sentry perspective, we should look at today's system log, and then we'll walk through one of these transactions. So I can open up the system log and select a single transaction, scroll to the bottom to see the beginning of the transaction, where we see document entered communications layer, and then work our way up from there, and we will see everything, the actual request headers to the actual request JSON payload. You can see that simple JSON payload coming in, and then all of the request processing that we've talked about, schema validation, injection detection, conversion, signing and encrypting, all of that's happening and is outlined in the logs. And then lastly, before we send that message out to the IoT Hub, we will show you the signed and encrypted XML message in our document as well, in our log file. And that, of course, is what you are seeing being picked up here on our application that's reading from the IoT Hub, these signed and encrypted XML messages. So while the transactions are still flowing through Forum Sentry, we can actually modify the policy while it's live, and perhaps maybe we'll take off the task list that we had enabled on this JSON policy. And what you'll see now in the application that is reading these messages off of the hub is that it's just a simple JSON payload. So I come in here and essentially disable this task list processing in Sentry, and then pull up the application that is now receiving these messages off the hub, and we can see here as they kind of trickle in, you can see these are just the same simple JSON messages that were put out by the client application right here. So we'll pull them both up side by side, and you can see as a message is put out through the simulated device application, it's then later received off of the IoT Hub in its same format. And so, of course, I can go back into Sentry and re-enable that task list. And then when I pull up my application that is collecting these messages off the IoT Hub, I once again can see these are signed and encrypted XML payloads. So now we can test one of the security parameters that we have outlined earlier, which was SQL injection detection. I can come in here and actually kill my client application, modify my source code to provide within the JSON payload some value that will trigger the pattern match expression that's defined in Sentry, which is completely customizable. But I can add '*OR to this device ID name, which is part of the JSON payload coming in. And now as I send this through, I get an error in Sentry almost immediately that's blocking these requests from coming through. And if I take a look at my system log here and just search this one, we'll see in yellow the message came in, validated the JSON, and then it triggered the pattern match SQL injection IDP rule and blocked that message. So if someone never made it through to the IoT Hub, that's Sentry detecting and then blocking that message. So we can kill the client application again. I can then change this back to the original text, remove the ''OR, and traffic will begin flowing again through Forum Sentry out to the IoT Hub. So this concludes the presentation today, demonstrating the AMQP 1.0 proxy capability for the Azure IoT Hub. If you have any questions, if you'd like a demonstration, a live demonstration, web session, feel free to reach out to Forum Systems Support or your account executive, and we'll be happy to oblige. Thanks a lot, and have a great day.